You may be familiar with the fact that in a triangle, any triangle, the interior angles would add up to 180 degrees. And this is true on flat space, if you draw it on a piece of paper or on a wall or whatever. But if you draw these triangles on different shapes, like around a ball or something, then it doesn't quite work in the same way. But with all of the shapes that we're going to be looking at in this unit, it's all going to be on flat space. It's also called Euclidean space after Euclid. Euclidean space. So in this example here, you can see that we've got to try to find A and B. And if we know that inside any triangle there's got 180 degrees in total inside that, if we were to draw another triangle over here, for example, then that would also have a total of 180 degrees. And then what you can see inside any quadrilateral, any four-sided shape, you'd have a total of 360 degrees. And we can use that fact here. So by adding together the 60, the 120 and the 80 degrees, we need to find out what's remaining then to find A. So by adding these together, we should find that it's 260 degrees. Oops, what have I done here? Ooh. Oh well. Yeah, it will be 260 degrees inside plus A, and then therefore A would be 100 degrees to make 360. So if this is 100 degrees, then B, well, angles on a straight line, you may remember, add up to 180 degrees. So therefore, oops, no, I should highlight that like this, 180 degrees like that. Now if A is 100 degrees, then B must be then just 80 degrees. Okay, let's scroll down and look at example 2. Now these lines, if you see them on any triangle, they represent what's called an isosceles triangle. That's spelt like this, isosceles. I remember it because it's got the SC in it for scalene. Scalene is a different type of triangle where you don't have sides that are the same at all. Isosceles has two sides which are the same, so that could be the same as that one, and I've shown that with these two dashes. But with a scalene triangle, there are no two sides that are the same. I just remember isosceles is spelt with the SC from scalene in it, although they're not actually linked. Anyway, let's have a look at the triangle with these two dashes. This means that these two lengths are the same, and therefore the angles C and D would be the same as well. So I could scribble this out actually, and I could write C because I know that it's the same as that one because it's isosceles. So how should we work out the rest of all this stuff? Well, A should be the first one to find out. Normally in test questions it'll ask for A, B, C and D, and it indicates that you should find A first. So can we do that? Yeah, because we've got in our triangle over here, in total we've got 180 degrees lying inside that triangle, and the 40 and the 30 add up to 70, leaving A to be 110 degrees. And now angles around a point, they all add up to 360 degrees. So then we just have to add 120 and 110 to get 230. And then find then what angle B must be to find 360, must be another 130 degrees. So B should be then 130 degrees. And then we can work out what C and D are. But now we know that C is equal to D. We know that the two angles that remain here will add up to 180 if you add it onto 130. So I'm going to write the formula out now. 130 plus C plus D must be 180 degrees. That would be my first line. I should write degrees here. And then I know that I can write D as C, so I can write again the next line down as plus C or plus 2C is 180 degrees. So 2C therefore must be 50 degrees and C which is the same as D, must equal 25 degrees. I hope that's been fairly easy to understand. This bold line here means that you can start the exercises.